Okay, science today is kind of similar to the other day in that we're just learning about another property of air. There is nothing today that you need to submit, okay? The same as the other day. The only thing you've had to submit so far is just only the assignment about oxidization, okay? So please make sure you have that done today. By really, if you haven't done that now, I suggest, again, just like I said yesterday, stop this video, make sure you have both parts done, and then submit it to me, please, on the Edmodo page, okay? Some people have also been sending it to me in a private message, which is also okay, but it's better on the Edmodo page and you can see the feedback right away. Okay, so today we are learning about our next property of air, which is air pressure. So on the fourth quadrant of your page, or I guess however you're choosing to set this up, please write down this. Property number 4, air exerts pressure. And this always makes me think of that Queen song, Under Pressure. Yeah, because it's true. Air does exert pressure. And just like this, downward pressure. Okay, so let's see here. Okay, so we're going to watch a cheesy video. You could write this in as the driving question, okay, that we're going to answer throughout the video. So what factors affect air pressure? While we're watching the video to find out, I'd like you to kind of leave space for 3 different factors. Okay, so there's 3 factors that affect air pressure. What are they? Okay, here we go.
That was a lot of leaves.
Yeah,
Let's go eat.
good idea. Oh, whoa!
That huge gust came out of nowhere.
How come wind is so powerful? You can't even see it.
Bad breath is invisible too, but it's pretty powerful.
Oh, gross.
Our breath and the wind are made up of the same thing. Air molecules invisibly floating in space. That's what gives wind its mass or substance.
And when it's windy, all those molecules are moving?
Like a herd. Sometimes they float gently in a breeze, and other times, like in a hurricane, they're blasted along at hundreds of miles an hour.
But what makes the wind strong or weak?
Everything from a breeze to a hurricane blast is caused by air pressure. That's the force with which air molecules push against us and everything around us. When the air pressure changes, so does the strength of the wind.
What makes air pressure change?
Here we go.
The height above sea level, the temperature, and the amount of water vapor in the air. Those 3 things make air more or less dense. When air gets colder and closer to sea level, it gets denser. That means the air molecules are closer together, so there's more air pressure.
So when air gets warmer and higher, there's less air pressure?
Right. The air molecules are farther apart, or less dense.
Hey,
Great.
It's like the leaves we picked up. When they're together...
Okay, actually, you could write that down for, this should be actually review from grade 5. There we go. Cold air is more dense. That means that the air molecules are closer together. And then the opposite for warm air.
And closer to sea level, it gets denser.
Okay.
That means the air molecules are closer together, so there's more air pressure.
So when air gets warmer and higher, there's less air pressure?
Right. The air molecules are farther apart, or less dense.
Hey, it's like the leaves we picked up. When they're together, they're heavy and hard to lift. But scattered around, they're lighter.
Love it.
Yeah.
Good example.
So it makes sense that dense air sinks and less dense air rises. The pattern of rising and falling air is called a convection cell.
Convection cell?
Check it out. Say we're at the beach.
You don't need to know
In a
this.
convection cell, the air over the sea cools and sinks. That's a downdraft. At the same time, the air over the land gets warmer and rises. That's an updraft. The cool, high-pressure air moves towards the land and heats up, replacing the warm air. And the warm, low-pressure air moves out to sea and cools, replacing the cool air. The movements of the air cause wind. All this air movement is affected by one more thing.
Lay it on me.
The Earth's rotation. As the Earth spins,
Okay.
it pulls the wind.
You
and
don't
makes
need
it
to know this
travel on
either.
a slightly curved path.
This is for
west
wind.
to east or east to west. It's called the Coriolis effect. Anyways, they're all kind of winds. They even have names.
Yeah, like a breeze and a gust and...
Well, no. Like polar easterlies, prevailing westerlies, and trade winds.
Huh?
Polar easterlies are winds that come in from the poles and blow east to west. Prevailing westerlies are warmer winds blowing in the middle latitudes, and trade winds are near the equator.
So, that gust of wind that blew through and ruined our hard work, was that a prevailing westerly since we live in the middle latitudes?
It probably was.
You know, this wind thing is pretty fierce. I never realized wind was caused by changes in air pressure, or that air pressure is affected
these
by
three
three
things.
things: temperature, height above sea level, and amount of water vapor in the air. And the convection cell stuff,
Yeah, I should
hot
know
air
that.
rising, cool air sinking, it's wild. But it's not as wild as the Coriolis effect. That's the spinning of the Earth that makes winds curve. Wind is invisible, but so powerful.
Wow, Sam, I'm blown away.
Well, it was quite a whirlwind of information.
Oh, the puns. They are just all over it. Okay, so, alrighty. So that's, okay, you did not need to know all the information from that, but you did need to know these three things, okay? 3 factors that affect air pressure, which you should have now written down: temperature, height above sea level, and amount of water vapor in the air. Okay, so they explained temperature quite well, because we know that the colder the molecules, should be totally reviewed from grade 5. The molecules have less energy, they're closer together, and then they're more dense. So that means they would be closer to the ground. And then the opposite for anything that's fast moving, right? Like kind of like the leaves that they said, they're moving quickly. They have more space between them. They're less dense. So they have less air pressure, okay? And then height above sea level, we're gonna talk a little bit more. And then water vapor. So basically, like, you don't really need to know that one like so much, but if there's a little bits of things like water vapor molecules within the air as well, then that is going to cause the air to be heavier. And as you notice, as it gets humid, especially like now, I find it's getting so humid here in Qatar. I went for a run last night and I could like feel like I could barely breathe, because literally the amount of oxygen you're taking in per breath has these little bits of water vapor. So it's like it's not as refreshing for your lungs to get that included within each breath. So that also makes it more dense and like thick and kind of just like harder to breathe. So I bet you can relate to that, because you probably all experience what it's like breathing in that, or you're about to. Okay, so the next thing is, okay, right. So we're gonna talk a bit more about air pressure to do with altitude. So air pressure, or atmospheric pressure, you might kind of also hear it referred to as, just a bit more like kind of technical, like because you're in the atmosphere, as we kind of talked about yesterday. There's different amounts of air pressure, which also kind of relates to gravity. So that's why our weight is different on Earth than it would be on the moon. Okay, right. So air pressure basically is the weight of the air in our atmosphere that presses down on things. So how much is above us is going to impact the amount of force that is acting upon us. So that's why technically there's different amounts of air pressure depending where you are on Earth. There's going to be more air pressure, higher air pressure, if you are like at sea level, like in Abu Dhabi, and then way less air pressure if you're like on the top of Mount Everest. Okay, and the other thing is air pressure is a force that acts in all directions. So it is above us, but then it's also, there's still air under us too, right? There is still air under here. So it's also kind of like pushing up on us. And there's also air molecules within our cells and like within our bodies, because it's also a fluid. So it's also kind of like pressing out. Okay, so, this is a review from yesterday. So this is okay, I do want you to write this down. So if you drew a 1 square centimeter on your hand, guess how much air pressure is pressing on this little square that you drew? Okay, we were talking about this, blah, blah, blah. We did this yesterday though. So do you think it's like 0, what is this? Tenths, hundredths, thousandths, 5 10,000ths of a kg, so like the weight of a feather. Do you think that's the amount of pressure that's pushing down on one square on your hand? Or 283 thousandths, the weight of a piece of bread, still like not really very much. 573 thousandths, this is good review of math, how we're saying numbers. The weight of 1 apple, okay, that's how much an apple is worth, so like half a kg. Or 1 kg, the weight of 1 liter of water. So that's like a liter of water, like a liter of your like water bottle. That is the weight of the air pressure compacted onto 1 square centimeter. I think you guys know the answer. It is, dun, 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 1 kilogram per centimeter squared. That is the weight of air pressure. I've seen that question pop up before on like tests. Okay, next thing is, why are we not crushed from air pressure? Okay, this is, I've already kind of gone over this. You don't need to write this down if you don't want to. But basically there's in us, and there is air under us, and there is, so all of this air pressure, and there's also air, like I guess like air fluid within us as well. Right, which presses upwards and then also out, so it kind of like equals out a little bit. Okay, now the next thing we're going to watch is a video on the effects of Mount Everest, like what the effects are on your body of if you enter somewhere like Mount Everest, for example, or Mount Kilimanjaro. I know that Rami's mom hiked Mount Kilimanjaro. Maybe other people have some connection to someone else who hiked Mount Kilimanjaro as well. Miss Nicole and Mr. Devone did as well, people who know them. So what I'd like you to do for this is in your notebook, sketch like a mountain like this, Mount Everest, okay, just like this, and then sketch like down here or even like lower, like Abu Dhabi, like at sea level, okay? And then as we're watching this, I want you to think, and also like pictures usually mean 1,000 words. So how can you sketch what air would be like? So I want you to sketch like if we were to be looking at the air molecules at Mount Everest, how would they appear to be different than the air molecules at sea level? They're going to be showing us this, so just kind of like sit tight as we're watching. Oh, you know what? Sometimes YouTube freaks out when I play. Okay, I'm just gonna actually play it here instead. Okay, just because sometimes YouTube.
Hey, adventure seekers! Looking for a thrilling new activity to pump up that heart rate? I've got just the thing. Plan a trip to climb Mount Everest. But before you pick up your bag, you should learn about exactly what it takes to plan a trip to one of the most dangerous climbs in the world. Standing at 29,029 feet high, this rocky summit poses plenty of dangers and challenges that can work against you if you're not prepared. First off, it's important to understand a little bit about the Great Mount Everest. If you've ever seen any of the blockbuster films about this epic climbing adventure, you know hiking up Everest is no joke. People who climb Mount Everest typically plan their climb during what they call the summit window during mid-May and sometimes November. Temperatures warm up a bit and the winds are somewhat calmer during these times. While it may sound logical to climb during warmer months like July and August, it's actually a pretty bad idea since this time of year is monsoon season and you'd be stuck in heavy rains. Aside from climbing during the right seasons, there are plenty of other precautions you should take when attempting such a challenging climb. Unlike hiking on your average hillside or shoreline, the height of this mountain is hard on your lungs. Mount Everest summit is higher than any other mountain in the world. So in terms of its height above sea level, it stands taller than anything else on our planet.
Cool.
Whoa is right. And at this height,
Okay,
oxygen levels decrease pretty drastically. It's almost as if the air is getting thinner, so to speak. While climbing Mount Everest, you'll notice yourself feeling more short of breath the higher up you get. Sure, you're exerting a lot of energy walking and climbing, but this shortness of breath is also due to the lower oxygen level. At an elevation of 29,029 feet, each breath you take only has 1/3 of the amount of oxygen as it would normally have at sea level. So clearly there are a lot of risks when it comes to climbing Mount Everest, which is why climbing it alone is probably the worst idea ever.
Okay.
It's best to plan the climb with a group. There are plenty of excursions you can pick from and plan is getting thinner, so to speak.
Okay, we don't need to watch the rest of it because they just talk about other things for like climbing, but we really care about this air stuff. Okay, so this is what like normal air would look like, or air, even maybe a few more of these air molecules at like sea level. But then, dun dun dun,
levels decrease pretty drastically. It's almost as if the air is getting thinner, so to speak.
Okay, so he said it's almost like the air is getting thinner, so to speak. And in actual fact, that is what is happening, even though we can't see it, right? Like we cannot see any difference in the air. We feel it through an internal reaction of like literally less oxygen molecules being swallowed per breath. So that means that less oxygen is getting into your lungs, which is then oxygen we know is needed to then circulate into our blood to make our muscles work. So if you have less that's coming in, your heart, that's why that's why your heart, they say like you feel like your heart rate increases. And I've done like a couple of hikes to like a really, really, really high altitude, not nearly anything like this, but still high enough. And it's crazy. Like you actually feel like I remember like my pulse would just like race like crazy. And it's because each breath that I'm taking in, even though it feels like a normal breath, there's not enough oxygen getting into my lungs that my lungs are used to getting to make your muscles work. So then your heart is like, whoa, what's going on? We still have to send the blood. We still have to get this oxygen. So then it goes faster. And just to try to like get more oxygen circulating, even though it's not getting as much in. So that's why people who were doing these really epic climbs, or like even any type of athletic sport at a really high altitude, they have to let their body go through a period of adaptation so that their heart and their lungs get used to working with less oxygen, and then they can still be okay. Because there's really bad things that can happen. You get like elevation sickness. I'm sure Rami could ask his mom about some of the stuff that she had to do when she was climbing Mount Kilimanjaro to prepare for this. That's not something that's super easy to do. But then on the flip side, which is also really cool science, is if you train, if you practice, so say there's like skiers, or no, it's not a very good example, like cyclists or runners, okay, that train, or Ethiopia, actually this is an example. They train at a really high, like Ethiopia is actually like quite a high altitude, kind of surprisingly. And when they're training there, then their body gets used to having less oxygen coming in to their lungs and then subsequently pumped to their muscles to make them work. So then when they go run or go compete in an area that is lower altitude, like such as like Abu Dhabi, then they're like, holy, like I take one breath in and then I have like all of these like many more oxygen molecules coming into my body. So then your heart's like, okay, this is a piece of cake. So then usually they do better because their body's used to working under much harder circumstances. So this is like, there's tons of science behind this. Like people spend like, they would do like a doctorate, like a PhD level study in this exact thing. And there's like oxygen, I've seen these things like oxygen chambers that athletes can train in to replicate altitude training because there's such amazing benefits to it. Anyway, that's like a little bit more detail than you need to know. But the key thing you do need to know is that like oxygen molecules are spread out and thin at high altitude, and then they're really like more compact at sea level or at like the lower altitude that you go. So it'd be like a progression, of course. Okay, that's it for science today. And yeah, so just like a couple little notes in your book. You don't have to submit anything. That's it. Okay, well done.